Hello, once again welcome to my YouTube channel on data analysis and research. Today I want to look at how to create a violin plot for multiple comparisons. So using GraphPad Prism. So this is what we want to create in GraphPad Prism. So how do you get this one done? So let's go to our GraphPad Prism so that I demonstrate how you can create this violin plot. So this is our data. So on this data sheet, we want to compare three variables. So the estimated glomerular filtration rate using serum creatinine alone, then versus serum creatinine and cystatin C, and then the two when you combine them. So how do the estimated glomerular filtration rate compare? So in GraphPad Prism, when you paste this data, automatically the system will create a graph for you, but this is not what we want. So this is a bar chart, but we don't want a bar chart, we want a violin plot. So we have to reformat this. So if we go to change, see change here at the top, then we see graph type, we select graph type. So here we can choose the violin plot we want. So if we go up there, you see box and violin plot, violin, so you select that one. So this is the violin plot, so you select this. So you see that it has changed. So we only want violin plot, so just select violin plot. There's also another version, the truncated type, but let's just do the normal violin plot for now. So you select OK. So this is what you get. So each of the violins here represent the three groups we showed. So we need to format this. So you click on any of the axes. So there will be a dialog box that will help you to format. So we go to frame and origin. We want the frame to be wide, not tall. When it's tall, it's very narrow, so we'll select wide. And then we also want to separate the x-axis from the y. So you select offset x and y axis. So you select this, then you say OK. You apply it and click OK. So you see it's now wider and also clearer than before. So you can see there are some lines within each violin. So, but they are not clear. So we have to format them to make them clearer. So the middle line here is the median, and you have the lower quartile and then upper quartile, but they are not clear. So so you place your cursor on one of the lines, and then you double click. So we want to format. So this is for the quartiles. So you see that the line is very faint. So let's make it. We'll leave it as a broken line, but we want the 1 point. We'll select 1 point, the thickness. But for the median, to make it different from the quartiles, we'll select a solid line and also make that one 1 point. But if we do so, just it will just format only one of the violins. So what we'll do is that we do change all data sets. So global, you change all data sets. So that means it will apply to all at once. But if you do for only one, you have to repeat that 3 times. So just select this and apply. So let's see what happens. So you can see that the lines are thicker. So what you see, the bottom, the tip here below is the minimum number, and this is the lower quartile, that's the 25th. The thick line is the median, the upper quartile, that's the 75th, and then we have the maximum number. The other tip is also the maximum number. Okay, so we can put our axis. So the y-axis, we have our estimated glomerular filtration rate. So this is the unit, so we can select. So it's measured in ml per minute per 1.73 meters squared. So let me select another one. Okay, so let's use this. So this is a unit. Here are just the variables. Since the names are there, you might not need to insert any title. So we want to make our writings a bit larger. So make it 14 all around. So you see that here we expand to 14. The y-axis will also make it 14. So in order to also distinguish between the different serum variables, we can color code these violins to make them different. So you can make it red, gold, green. So make this first one red. So you see the border color is black. So here you select red. So since you are doing individually, you can use a global, which will make all of them red. So this one will make it gold. So use gold color here. And then the last one, combine creatinine and cystatin C, will make it green. So select green. Okay, so you see, so this is our violin plot. So each of these is representing the minimum number or minimum value, the lower quartile, median, upper quartile, and then the maximum value. So now, but we don't know, are these statistically different? The distribution of the data, are they statistically different? We don't know whether this value or median is higher than that or that. So we don't know as of now. So we have to go back to our data and perform a one-way ANOVA using either parametric or non-parametric means. So you select one-way ANOVA here from Analyze. So we want to compare the tray. So if you click OK, so here you come and now select what you want to do. So no matching of parent. Here there is no matching. So you no matching of parent is selected. So other depending on the distribution of the data, are you using ANOVA for parametric or non-parametric? That's the Wallis method. So for our data, this data we have is non-parametric. So I'll select use non-parametric test. Then because we want to compare each value, each median to the other, we'll come to multiple comparison and choose compare the mean rank of each column, the mean rank of every other column. So that's a multiple comparison. So if you need other options, you can come here, residuals and all that. But just these two are okay for now. So select OK. So you see, so this is the results. So you see that when you compare all three groups, there's statistical difference. So you can see if the p-value is less than 0.001. But aside that, where is the difference coming from? So that is where you now go to multiple comparison. So you select here. So you can see that the difference lies between serum creatinine and cystatin C, and then between serum creatinine and the combined creatinine and cystatin C. That's where the difference is. So you can see the summary, the p-values are less than 0.001. Then the adjusted p-values are also here. But between cystatin C and the combined, there is no difference. So you can see no difference. The p-value is about 0.05. So we have seen where our difference is coming from. So we have to go back to our graph, our chart, and now indicate that. So you can remove this title. So to indicate where the difference is, you have to go here. You select a drawing tool. So you click. So you want a drawing tool that you can insert a value or an indicator of significance. So we select this one. So it will display as a pencil or pen so that you can draw. So you right click or you hold on the left side of your keyboard and then you drag. So to insert a line. So from creatinine to cystatin C, the p-value is less than 0.001. So that's a 3-star. If you want 4-star, you can select. If you want to use hash, you can select. So let's use. If you also want to insert the actual p-value, you can also do that. But let's use 3-star. So it means that between creatinine and statin C values are significantly higher than creatinine. Then also comparing the combined and creatinine, there's also a difference. So we'll go again and select this, and then we start from creatinine. You hold right click and then drag it to the combined. So it's also trace star. Okay, so that is so in your legend you can define what trace star means. So you can say p less than 0.01 is equals to trace star. So you define that. So that is how you create the violin plot. So you can do just binary. 2 comparisons can be done. You can also do multiple, 3, 4, or 5, and then indicate where there are differences. So when you perform an ANOVA or non-parametric ANOVA, you can decide to display the results in this form. So this is how we did, and then we had this plot. So it's good for your research, particularly when you are writing thesis, dissertation, or a manuscript for publication. You can always use this violin plot to display your results. So thank you much for uh, subscribing to the channel, and thank you for watching. Please share, like this video, and also invite your colleagues to subscribe to the channel. So see you again next time, and thank you.